Hi. So let's start now refactoring our character movement script. What I'm going to do first, and with the basic idea of what we're going to be doing, is we are going to first pull out some functions, some functionality from our character controller, our character movement, sorry, is update function. It does a lot over here. Let's pull out some of these into helper functions, and we'll put it in a new class. So, these things like checking for if we're grounded and moving the coyote timer, this could be its own function. This could be its own function. Getting the inputs could all just be its own function. So that way we can reuse them later on. And we'll put them in a new script that we are going to get working with this script. So instead of this update function calling all of these, it's going to call the helper functions we make in the new class. They're going to do the exact same things. We're just refactoring the code. We're like changing the layout of it, basically. From then, or after that, we are going to, and this won't be in this video, this will be in the next video, we're going to define a new interface for our states. This interface is going to be implemented by all the different states our character can have. So move, sprint, jump, etc. Those are all going to be implemented through this interface that we make. So we're going to make like an interface for our states, going to be called iState. And then we're going to have different states. We can have walking state, sprinting state, jumping state. And we are going to create a state machine. So this state machine is going to control the switching of the states in our player. And finally, our character movement script, instead of having any of this code in here, it's going to have a state machine reference, and it's going to just use the state machine, and that's going to run our character. So those next two will come the following videos. This video, let's just focus on refactoring this code into a separate script. So what I'm going to do is I'm going to make a new script, and I will call this one character motor. And the idea being like this class is going to have all the functions that kind of define the player's movement stuff, their motor, the things that gets them moving. It's going to be in this class. So to start, I am not going to need any of this stuff here, or any of these variables. We don't really need them in this class anymore. So I'm just going to take them and put them in our new class. Oh, did it twice. There you go. Just put them in our new class. And slowly, let's just get rid of all these for now. I'm going to have a bunch of errors here. That's fine for right now. We'll, work on fixing them as we create our character motor class. So to start, one of the things that's going to stay the same is the start function. Here we just get the input manager and stuff. We're going to do the same thing in our motor. So in start, let me just make sure we get that. And we can delete that from here. Next, what we want is these functions that we have here, or this functionality rather, I should say. We want to move that into separate functions in the character motor. So we don't need an update here for now, but what I'm going to do is create a public void get inputs, and all that's going to do is get our inputs just like we did here. So I'm just going to cut that and paste it here. And like that, we're going to redo all of the functionality that we have over here. We're just going to break it out into as many functions as we can. So I'm just going to go ahead and do that, and we'll kind of talk through it as well. So then I have public void get camera transform. And that's really just going to be this. It's just going to set this camera variable. Next, we're going to have to get our facing direction right. Now, with the facing direction, you'll see that I make these two new vectors here, vector 3 forward and vector 3 right. So I'm creating these new variables, then I'm projecting them onto the plane. I could make those variables up here, for example, I could just make them permanently here, vector 3 forward and right, then I could use them anywhere. Instead, we're going to use a different concept known as an out variable. So if I just type out where the parameter goes, and then type the variable name, vector 3 forward and out, vector 3 right. And what this does, and we'll see this again being used, is now these parameters, they're not passed into my function. Instead, they can be, we set them, and the person calling the function, they can save things as these variables. Again, we'll see that working, but just know that now with this keyword out, we're saying that if you call this function, whatever you put for forward, whatever parameter you pass us, we're not going to be using it, we're going to be setting it. So I'm going to set an output, a vector 3 forward, and I'm going to set a vector 3 right using this function. And this is going to do the exact same thing that was done here, except because we're using this out keyword, we don't need to re-instantiate these or reinitialize them. We can just call it as is. And again, we'll see this being used. Just know that this forward is setting this output forward, and this right is setting this output right. What else do we have? So let's construct our moving direction. So that's going to be vector 3, let's call it get relative move, because that's going to get our relative moving direction. And this, again, just going back to our code, this takes our forward and our right. Forward and right don't exist here quite yet. And so good practice is, rather than having these variables kind of hard-coded into the class, when we can, let's just pass them along as parameters so we can use them in different ways later on if we need to. So this is going to take a forward, and it's going to take a right. That's just going to do the exact same thing that we did here. Let us just normalize the move. So we'll do move.normalize, and then we'll return move. Okay, what do we have next? So next we can deal with the coyote time, just resetting it, So we can deal with that, just updating the coyote time, as we need it. So we'll make a new function for that, void update coyote time. Or I guess I should say update coyote timer, because we call it a timer. And that's just going to be the exact same code as it here, where if we are grounded, the coyote timer is just going to be always resetting. If we're not grounded, we can update it using the delta time. Then we want to deal with jump. Same thing, jumping is just going to be this function right here, where, if the coyote timer is greater than 0 and we press the jump input, we jump. Next is gravity, so I'm just going to make a function, void apply gravity, put a space there. And I know that's just gravity velocity.y plus equals gravity multiplied by time. So again, just the same thing that we have here. We want to be able to construct our movement. So let's deal with that next. I'm just going to make it one function. So, here we construct the horizontal and the vertical movement separately, but let's just do it together. So instead, we can do void construct movement, and it, just like our horizontal and vertical, right? These two vector 3s that we're making, we can set them as output. So output, or out as the keyword is, vector 3, horizontal, and we're going to have an out for vector 3 vertical. So vertical is kind of easy. It's just taking the gravity and multiplying it with that. For horizontal, I had it done here where we set it, two different ways depending on the sprint input. I'm just going to do that using the ternary operator, so things are like, in one simple thing or in one simple line. I'm going to make a new variable called speed. And here I'm just going to say if we are pressing the sprint input, then we're just going to multiply moves, or speed is going to be our move speed multiplied by the sprint multiplier. Oops. Multiplied by the sprint multiplier. Otherwise, it's just going to be the move speed. So if this sprint input is true, it's going to be move speed times multiplier. Otherwise, it's just going to be move speed. And then the horizontal. Yeah. Horizontal will just be equal to the move, or speed multiplied by, so we need a variable here. We need that move direction. So we will take that as a parameter. So I can just do vector 3 move. It's important to note, if you're using these out variables, they have to come at the very end of your function signature. So I'm not allowed to do this where I add this, here. This has to come before any output variables. So we're going to multiply it by that move direction. And because we're moving, we're going to multiply the whole thing with time.delta time. And I made a mistake here. This is just going to be vertical, and we replace this with v. So all we're doing here is we're constructing our vertical output. That's going to be this vertical here. We're constructing our horizontal output. That's going to be this horizontal here. And what else do we have left? So we have done that. Right, the last thing we need to do is actually move the character. So we will do it the same way. We'll just make a void move character, which is going to take a vector 3 horizontal and a vector 3 vertical. And all this is going to do, just like we did in our other one, was just call move with the horizontal plus the vertical. So now we've taken all the functionality that was inside our update, and we have put it into this character motor class. Right now, our character movement is totally empty. So let us just use the motor as is and get it working in character movement so we can see, what we had before exactly. Let's just get that working as is. So what I want, or I don't even need to make this a serialized field. I need a reference to our character motor. I'll just call it motor. And on start, we're going to get that component. So motor equals get component. What is the type of component? Well, it's a character motor. And then let me just split screen this so it becomes a little easier to look at. We just need to call these functions kind of in order. So, if I look at this here, first I need to call motor.read. I called it get inputs. Then we need to get the camera transform. Then the next function we need to get is the facing direction, right? But if we look at the facing direction here, it has an output vector 3 forward and right. So let me just make those two vectors, vector 3 forward, comma, right. And this is this way of just writing the name of one variable, comma, the name of the other is just shorthand for saying create a vector 3 call forward, create a vector 3 call right, just a shorthand for that. So then we want to call motor.get facing. I made a mistake here. I didn't make this public. So I'm just going to go ahead real quick. It looks like I forgot to make a lot of these functions public. I'm just going to go ahead real quick and make them public. There, I just made them all public. They're private, so I couldn't call them before. So now we can search for motor.get facing direction. And we can pass it our new forward vector variable and our right vector variable. And so what this is going to do is it's going to set our forward vector to this right vector. And we have an error here. Let's take a look at why. We just need to also pass it with the out keyword. So this needs to be out right and out forward. And so what this is going to do is in our get facing direction function, if I can find it here, there you go, get facing direction. We're setting this forward out to our project on plane and this right out to our project on plane, which is going to be outputted as these variables here that we have created here. I've just named them both forward, right, the same as a parameter name. But, you know, if I had called this something different, like forward facing direction, I would also call this forward facing direction. And so this now forward facing direction is what this forward is going to be stored as. But I don't want to do that, just to keep things more consistent. You know, just name them the exact same. Then let's get our move direction. So I'm going to make a vector3 move. And get our relative moving direction. So motor.get relative, or yeah, I called it get relative. Okay, looks like we're having more errors here. Again, it added system numerics for some reason. And get relative move isn't working. I have now made it public here, so public. And again, these are small issues we run through when refactoring code. It's perfectly fine. As long as we can read the output, we should be able to fix them fairly quickly, right? So we got the relative move. Next, we can update the coyote timer, right? So that is reading the inputs, and we've done this part. Next, we're going to deal with jumping and gravity. So that was motor.update coyote timer and motor.jump. As well as we need to call motor.apply gravity. That's the last kind of big jumping thing. And then finally, we're going to construct the movement vectors, and we're going to move just like we did last time. We got to do the same thing this time. So I'm going to make 2 more new vector 3s for our horizontal and our vertical. And with that, we're just going to call motor.construct movement, pass the move parameter along with horizontal and vertical. And again, because it's an output, we need to use the out keyword here. And finally, we're just going to call motor.move character with our new horizontal and vertical. And let me just make sure, move character, we take horizontal first, then vertical. We're doing the exact same thing here. So save that, and you know, all we've done, you can see our update function has drastically reduced in size, because instead of like having all the logic here, we're calling some functions. This is also really good, you know, even though this might seem like we're typing out more code, this is good because now when someone comes in, they read this, they're not getting confused. They're not looking at the implementation of these functions. Instead, they're understanding the actual flow of the function. We're getting inputs. We're getting the camera transform. We're getting the facing direction. We're constructing this movement vector, and then they can see the flow of our jumping. So even for you, even if we're not someone else, this is the code we wrote. This is easier for us to look at because we've kind of separated out the implementation from the functionality, and that way, you know, not only can we reuse these functions, but also it's a little easier, well, much easier to read because we don't have all this code there. And instead, if I want to get to know more about a certain function, like for example, how jump happens, I could go to its implementation and I could see that here. So I don't need to get into the weeds of it to make use of it. And that's like a big benefit of, breaking things out into more reusable functions. But anyway, if all was good, let's go back to Unity, and it should just be the exact same as we had it before. So we need to first add the character. It's giving an error here, but first I know we need to add our character motor to our player and then see what that error is about. So we add our character motor. We try and run it. It says there's an error. Let's just see what that's about. Okay, it was as simple as I didn't save it. Usual errors. So I've saved it, the error is gone, and our character still works the exact same. Okay, so that was a fairly simple thing that we just did. We kind of just refactored our code into different functions, with the reason being that now we can use these functions. Our states can now use these functions rather than needing to re-implement them on their own, because we're going to be able to move in the air. We're probably going to get the camera transform in the air. We're probably going to want to get the inputs regardless of the state. So now we have these helper functions is what I'm going to call them. We have these functions to help us do these things, and we don't have to keep rewriting them. Makes it useful for us. Anyway, thank you for watching.